Hello again. We are all set to start developing the functions for circular linked list. You can see the node structure is same as we had in case of single linked list. Nothing is different here. We have this circular linked list structure. Only we have the tail pointer there. We do not need a head pointer because the next pointer field of the last node will give us the address of the first node. So we don't need to keep the head address of the first node separately in a pointer field like head. The node count is going to hold the count of the nodes as usual. The init list method is just same as the single linked list. It's going to initialize the list parameters. It will initialize tail with null and 0 to node count. Create list from random numbers. It's going to create the circular linked list with some n numbers of nodes. Each time it will call the insert node function and will send some random data to the insert node for creating the linked list. The insert node function will always add the new node at the rear end of the circular linked list. You see that it's receiving a list pointer and the data that it should put there in the new node that it is going to insert. The print list function is going to print the content of each node of the linked list. Now here is a special situation that we are going to face in case of circular linked list. Now when we traverse through the nodes of the circular linked list, we don't get a null there at the end of the list, right? We need to just implement some different mechanism for terminating the while loop when we traverse the circular linked list. We'll see how we can do that. The find method is going to find a target data in a node. If that exists, then the find method is going to return the address of that node. Otherwise, it's going to return null. The delete node method is going to delete the node from the front of the list. It will always delete the front node of the circular linked list. Now this insert node and delete node, these two functions will actually build the circular queue. If we use these two functions, we'll actually implement the circular queue. That will give us first in first out order using the circular linked list. The init list method, as you can see, it is initializing tail with null and 0 to node count. Okay, here is the insert node function. This is going to add a new node at the end of the circular linked list. That means to the rear end of the circular linked list. It receives two parameters. The first one is the list pointer. That means the address of the linked list object, circular linked list object, and the data that we want to keep there in the node. We have created the node. I have already written the code, as you can see, and the malloc function call is just same. It's creating the node and returning the address to the new node pointer, and then we are keeping the data inside the new node pointer. These things are just same. Now we are adding the node here. This is the actual code for adding the new node at the rear end. Now there are two situations. One, if the linked list is empty and this new node is the first node, that means the last node of the linked list. And the second one is that there are many nodes and we need to add this new node pointed by this new node PTR at the rear end of the circular linked list. So first of all, we are checking if the linked list is empty or not, as you can see that in line number 47. If the linked list is empty, then the tail pointer is null, obviously, and so we need to add this new node that is pointed by this new node PTR with the circular linked list, and this new node PTR's next pointer field, this one, should point to itself because it is the first node, it is the last node. So that's what we are doing here. You can see that new node PTR arrow next, that means this particular pointer field we are referring, that is assigned with the address of the current node, I mean itself, that is 1000. So we are assigning 1000 here. So this is pointing to itself, something like this, and we are not going to the else part. The else part is for the linked list when there are many nodes. We'll see that later on. Okay, now we come here, lstptr arrow tail equals new node ptr. So we are assigning this 1000 to the tail, and so the tail is now actually containing 1000. This is the tail. So this tail is right now pointing to this last node. Okay, so we have added successfully the first node of this circular linked list. Now we'll see how we can add a node at the rear end, how this else part works actually to add a new node at the rear end when there are many nodes. Okay, so this is the situation when we have many nodes. We have considered that the linked list currently contains 3 nodes, as you can see, and the address of the first node is 1000, and that is here in the next pointer field of the last node. So the next pointer field of the last node is pointing to the first node. This is truly a circular linked list. Now we need to add this new node that we just created at the rear end of this circular linked list. So the node count is right now not equals 0. So we come to this else part, and you can see that new node PTR arrow next. That means we are referring to this particular pointer field, the next field of the new node pointed by new node PTR. So new node PTR arrow next equals LST PTR arrow tail arrow next. Now that is tail arrow next means 1000 that we are copying here. So this next pointer is right now pointing to the first node. Okay, and then what we are doing in the next line, at line number 52, LST PTR arrow tail arrow next, that means we are updating this next field of the current last node. We are updating that next field. Okay, so this next field is assigned with the address of the new node, that means 4000. So 4000 goes here. So this particular thing is not there. That's not going to point the first node anymore. That's going to point the newly added node, I mean this one. Okay, now we need to just move the tail pointer to the new node that we are doing here. As you can see, tail is updated with the new node's address. So tail is no longer 3000, it's 4000 now. So tail will be pointing to this new node. And we are done. So that's how we can add a new node at the rear end of the circular linked list. In the next tutorial, I'll be actually doing the delete operation. I'll explain how the delete first works. Now here, we'll be always deleting the first node from the circular linked list. So you can see that this is the front end of the circular linked list, and this is the rear end of the circular linked list. So if we are deleting from the front end using the delete operation, then it's always going to follow the first in first out order, as we are adding using the insert operation to the rear and deleting from the front. So that's how the circular linked list will behave, like a circular queue. So let's go ahead with the next tutorial where I will explain the delete operation. Thank you very much for watching.